Alright, so this is the last video assessment of the year for Unit 11. So to start off, we're going to be going over bell curves, in which it's just a graph for a normal distribution right here, and it gives all these statistics based on statistics from real world examples, such as scores on a test with several students. So to start, we're going to be going over the percentages. You have 68%, 95, and 99.7%. It gets smaller as you go up. And then right here you have 34, 34, 35, 35, and then it correlates from the left to right. And so in the middle you have the mean, which would be the middle of scores. But right here you have standard denominations, which are intervals away, like interval differences from the mean. So say the mean was 2. So the mean's right here. So right here would be 0, -2, and -4. This one would just be 4, 6, and 8 right there. So those are standard denominations. Then you have all your percentages correlating to where something is on the graph, say a specific score, or a wide range of scores. So normal distribution isn't always represented in the bell curve form of a graph. It can also be in a bar graph, but as you can see, even though it's not a bell curve, it looks like it. So you can almost outline it being a bell curve like that, because it starts out smaller, it goes up, 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 and then it drops just as a bell curve does. It's just represented in a different way. Okay, so the percentages in a bell curve in a standard distribution graph, the 68, the 95, and 99.7, they all correlate to what, say, like I said, test scores are. So 68% of scores would be within one standard deviation of the mean. 95% would be within 2 standard deviations. 99.7 would be within 3. So 68% of the scores, 1 standard deviation. 95, 2 standards. And 99.7, 3. Alright, so next up we have dot plots, box plots, and histograms. So for this particular question, it was the amount of TVs that students have in their household. So here is all of the data with the number of TVs. And so the first plot we're going to be doing is a dot plot. So what we're going to do is we're going to draw the line with 0 through 7, and for each number, 0 through 7, we're going to put a dot above that number. So for kids that had 0 TVs, there was 1, so we put 1 dot. For, say, kids that had 4 TVs, there were 4 of them, so there are 4 dots above it, and so on. And that's pretty much all a dot plot is. It's just the numbers with the amount of each number plotted above it. So after that is box plots. So this one right here is just it's really close to a dot plot, except you, instead of putting dots, you're just putting a line at the mean, and then putting a box within each standard deviation. So the standard deviation is 1, so it's 2. So that means you're going to have one at 1 and one at 3, and then you're just going to have the whiskers stretching from 3 to 7 and 1 to 2. So this right here is a histogram, essentially just a bar graph representing the previous data from the box plot and the dot plot. So this is just, you have the frequency on this side and then the numbers of TVs on this side. So pretty much for each one you just draw bars. So for 0 to 2 there was I believe 8 kids, 4, 15, and so on. So it basically it's just a bar graph. Alright, so now I'm going to be showing how to find all of this data right here, the mean, the standard deviation, median, 5-number summary, IQR, and if it's unimodal, skewed right or left, and all that data just based off entering all the numbers given into my calculator. So for mine, I just put everything into these lists, and then I hit calc, and then I press 1 var, and then it gives me all the numbers I need. It gives me my median, it gives me my mean, standard deviation, 5-number summary, the Q1 and the Q3, everything I need in order to find the IQR, and as well as just display all the information. So the data that I got was the mean was 2.53, standard deviation is 1.5, the median is 2, 5-number summary is 0, 1, 2, 3, and 7. The interquartile range, IQR, the formula for that is Q3 minus Q1, so it's 3 minus 1 equals 2 for the IQR. It is unimodal, skewed right, and the median is 2, IQR is 2. So relative frequency is just based off of a bunch of data like this right here. 30 students in a PE class ran 1 lap around the track. The times recorded in seconds are below. So these are all the times that it took for people to run around the track. So what we've done here is we have a whole table that displays all that information. So we have the lap time right here, 40 to 50, 50 to 60, so on all the way up to 110, and we have the frequency. So the frequency is pretty much the same thing as like the dot plots, as in there would be 1 dot above 40 to 50, 3 dots above 50 to 60, and so on. Relative frequency. So because there were 30 numbers, it's going to be 1 out of 30, 3 out of 30, 5 out of 30, 9 out of 30, 7 out of 30, 4 out of 30, and 1 out of 30. So what all we do is we divide 1 divided by 30, 3 divided by 30, and we get all these decimals, which shows the relative frequency. So here we have another histogram showing the data that for the laps that the students ran. So we have 0.10, 0.20, and 30, and then we have all the times, and then over there we have all the bars showing how many times a certain time was recorded. So right here we have all the data for like the mean, median, standard denomination. It's symmetric, it's unimodal, it's center, and the spread is standard because it's symmetric, as well as the center because it's symmetric. Mean was 76.1, median 75.5, and standard denomination 13.8, which is the same thing as the standard deviation. So right here we have a -1 standard deviation. For the IQR, it's 76.1 minus 13.8, so you get 62.3. Median is 76.1, and 1 standard deviation. So this right here is the percentage of the observations that landed within the intervals of the standard deviations that I just showed. So it's 20 divided by 30 equals 0.67, times that by 100, and you get 67%. So this is just the same thing as before. All the data, the 2 standard deviations, the +2, you're going to have the 16.12 times 13.8 that you get up here, 103.7, then you're going to do 29 divided by 30 to get 0.960, and then you're going to times that by 100 and round up to 97%. Of the observation, for the observation. So for the relative frequency, the percentages are approximately normal and are closer to expected. So this year was definitely a learning experience. I learned a lot this year and now too. And I feel now, after taking this class, I feel a lot more comfortable doing math, which is one of my goals, because math has always been my weakest subject, so I feel more confident going into next year now. My goals for this year, probably my biggest goal was to make the varsity lacrosse team. I succeeded in that goal, and then my academic goals was to do better in math and overall my other classes, and I feel like I somewhat met that goal. because I have a greater understanding for math, and actually my grades are better than they were last year. Except I think I could have balanced everything a lot better. So definitely going into next year, I'm gonna work on that and make sure I do all that better. So taking lessons from this year and using them later in life, I'm definitely going to be using all of the life lessons that we were taught. Those are all super valuable, and I won't be forgetting them. Also, just to work, because that's going to be the key to being successful later in life.